Okay, so let's start with this simple class. And again, I will focus on dynamic fields in order to see the need to manage the memory and to avoid memory leaks. So the need to implement the destructor and to properly implement the set methods. Okay, because I will use a lot of standard namespace values, so I will also go for the shortcut using namespace standard. Okay, so let's take the product class again, but I will focus only on dynamic fields. So for example, last week we had the name as a string. Now let's pass it as a dynamic char array. Now, one of your colleagues asked me, do we do the same with static arrays? We talked about static arrays and the difference, but let's take another one. So let me explain you again why for static arrays we don't need to deallocate, because we can't allocate space in heap. So let's say this is the manufacturer name, manufacturer. Okay, so for this one I will ask for 50 characters. I think that will cover all possible names. And here we also had that sold items records. So int sold items records, okay, or sold items per month. Yeah, let's call it this way. I think it's much more suggestive than the name that we used last week. And here I will say int number of months. Remember what I told you, including last week at the course. The first thing that you do when you define a class, go for your own default values. So when you do this, make this to be your habit, because if you create this habit, this will follow you through all your career as a developer in any language, not just C++. So in this case, for this name, I will say, hey, we don't have a name yet. It's a pointer, so let's make this clear. We don't have a name, it's null. And remember, we did that last week. When you will print the name, the product name, you will check to see if the name is null, because if you print this directly, it will crash. But now you will check it. So always check your pointers before using them, compare them to null. Okay, now this is a static array. So for example, here you can't say null because that's the difference. This is just a pointer pointing to nothing. This is a pointer. Remember, all array names are pointers. This is a pointer which is already pointing to this array of 50 characters. So that's the difference. Here is like you need to, if you want this array, you need to, I don't know, cook your own dinner. Okay, so go to the market, buy something and make something out of them. Just cook your dinner. Now this is like a free lunch. Okay, so when you define a static array, you already get for free these 50 characters. Now this is a catch. For this free lunch, you will always have the same menu and you can't change it. Okay, so yeah, I think it's lunchtime, so that's why I'm thinking at this example, but nevertheless, so this is like having a free lunch with the same menu. You will always get these 50 characters. Now here, you need to do work to cook your own dinner, but you have the power to change the menu. So the power of pointers is that if you want to create new arrays in heap, you have the power to do it, and this pointer will just store the address. Here, you are left with this array of 50 characters. You can't change it. This is it, okay? So nothing is actually for free, okay? Here you get it for free, but you can't change it. Here you can create it. You need to work on that. You are responsible for deallocating and avoiding memory leaks, but you have the power to recreate this anytime you need it, okay? So here I will just say, because I can't say null pointer, I can initialize this with empty string. Okay, sold items per month, the same logic, null pointer, and number of months equals 0. Okay, so right now, we know we have this, this class. So the first thing that we should do is to be able to test it in order to create products. Okay, so let's say here we want also to define the main function. Okay, so we know that we get the default constructor for free, but I don't want to use it. I just want to implement one which will ask us for different values. So here, if I will try to define the constructor for a product, which will ask for all those values, it will be like this. So we will ask for a name. Okay. We will also ask for the manufacturer. Remember, even if you expect a value for a static array, we talked about this several weeks ago. Always ask for a const char asterisk, even if we expect a value for this array here. Okay, manufacturer. Okay, and we need this data here. Sorry, my mouse just moved. Again, here, I will also pass this as const because I don't want to change it. Remember, we talked why we pass input arguments with const, because we don't want to change them by mistake. Okay, and here I will say previous data int number of records. And this number of records is related with number of months. Now, someone asked on Slack regarding also the assignment, that was the, let's say, correlation between values that you receive here and attributes. So there is no rule saying that the variables that you receive here should have the same name. The idea is to actually check if they correlate in terms of logic or sense. So can we use this data in order to initialize something here? So if this is the previous data, which is historical data, it means it's related with the sold items per month, because this is the historic data. And here, number of records, if this is the number of values here, this is actually the number of months, right? So they correlate even if they don't have the same names. Okay, so right now you have the constructor. So we can actually start implementing it. But if I will do all the stuff here, for example, if I'll try to copy the name, copy the manufacturer, this constructor will increase in size. And I think it will have like 30, 40 lines of code. So if you have a bug there, it will be difficult to find it because you need to go through 45, 50 lines of code. And maybe later you will say, yeah, but wait a minute. I want to create a product, which is a new product. So I don't have historic data. It's new. I just add it to my online shop. So in that case, I will need only these values. And I just realized we forgot the price. So let's ask also the price here. So I will need only these values. And where is the price here? We don't have the price. Let's also add the price. Okay, so I will need only the name, the manufacturer, and the price. So you will have another constructor. And again, you can have many other constructors, which means every time you implement a new constructor, you need to write again 20, 30 lines of code. In many cases, you will just copy paste the code from here. So we don't do that. We manage these attributes one by one. So let's set the price, the default price. So just add the price here, float price equals 0. Just add the price here. And now this will be the second constructor, which requires the name, the manufacturer, and the price. Okay, so take these attributes one by one. Define set methods for them. Even if you don't define the set methods public, you know you have the power to choose which one is public. But just deal with them one at a time. It will be much more easier to handle complex solutions, okay? Including classes that you may write for assignments, okay? Which they require a lot of lines of code. So let's define the set method, and after that we come back here and we finish the constructors. So let's start with the set value for the set method for name, for example, because we want to be able to update the name, maybe correct it, change it, whatever. So void set name. Okay, again, I will ask for a const char asterisk name. Okay, and today I will use this approach. I told you also at the course. So if it's easier for you to distinguish between the input values and the attributes, even if we are using this, you can use this pattern. Okay, so in these methods, you define this input as new that, because you know it's the new value. Okay, we also know that here we should validate. So let's validate also for null. So if new name is null, when you check with equals, this is a common error. You will do this a lot of times. I'm doing this from time to time. Watch out here. Don't write a single equals, okay? Because sometimes you don't get any compiler errors and your program will run differently. So this is a very nasty bug in C++. That's why in Java, you need to check only against true or false. So they try to remove this error here that we can easily create it in C or C++ by using only one equals. Okay, so if the new name is null, which means there is no new name here, or string length of new name. And we had here a rule. Let's say if the name is shorter than 3 characters for the product, we said this. Let's throw an error message. So here I will say throw exception, and here I will say name missing or is too short, or is too short. Okay, so if that's the case, the set name will interrupt, the program will crash. Now else means you are here. Remember, throw behaves like a return. It will terminate the function execution. So if you reach this spot here, line 24, it means this has not been executed. So that's why I'm not writing else.
To show an exception, don't we need to include exception at the beginning of the program?
No, in the assignment, you have the, are you referring to the assignment that you have a special exception or?
Yes.
Yeah, so for the assignment, we were including exception because the assignment had the particular exception defined. Okay, and that's why you need the exception. But in this case, if you just want to use the exception, it's not mandatory. We can include it, but it's not mandatory. Okay, so it will work also.
Only if it's special?
Yeah, only if we extend exception, and we will understand that because in 3 or 4 weeks we cover inheritance. So then you will understand why how we are creating special exceptions and how to use them.
Thank you.
Okay, thank you for the question. So if we reach this spot, it means it's okay. So now let's change the name. And we talked last week about shallow copy. Fortunately, because we pass here with const, we can't do easily this mistake. I can't easily say name equals new name because it will give me a compiler error here. But if you don't pass it with const, this is possible. And here you create shallow copy with all the side effects of shallow copying, which we covered last week. So that's why this is another motive for using const here. It's also protecting me for this easy mistake. Okay, so we know that we need to do deep copy. We need to create our own array and copy there the new name. So here I will say this name, new char of string length of new name, the value that I received here, +1. And after that, we copy the value from new name into the new array. So string copy _s, the destination is name, and the number of characters that we want to copy is this +1, and the source is new name. Okay, so at this point, we are avoiding the shallow copy by doing deep copy. We create a new array, and now we copy the value into the new array from this input. Okay, So now we know how to change the name. Again, here we have that bug, which I said to you, we are creating right now, because here we are creating a memory leak. Okay, so let's implement this set name and also set sold items per month. And after that, we come back and we cover again why we are creating here memory leaks. And then we will also implement the destructor. Okay, so we will have a memory leak fix, let's say, in our program by covering all these cases. But for the moment, we know here we are creating a memory leak, and we will fix this in the next minutes. Okay.
I have a question.
Please.
Can we use else there?
Yes, we can. So here you can actually say else, open the brackets, and do this inside the brackets.
Okay, so it is correct like this.
Yeah. I'm not writing the else because you see it's just increasing the size of it, because I know that if you go on throw, so if you go on the then branch, if this is executed, set name is terminated instantly. This is like having here return, which means this everything which follows the if will never be executed if you execute this. So in that case, else is not required. But by the book, you can also have it like here. So we can leave it like this. Okay.
Okay, thank you.
You can choose your own style. So if you like to have your source code like this, to have the if, then, and else, it's okay. So you can do it like this. So I will just leave it here. Okay, so yeah, it's equivalent. Now, if you don't have here a throw or a return, then else is mandatory. Okay, so yeah, I think it's better to write if else, because sometimes you can be in a situation where you don't terminate the function here with throw or return, and if you forget else, that part will always execute. So yeah. Okay, so this is the set name, which is avoiding the shallow copy, and we copied the name. Now, how do we do a set manufacturer? Okay, so that was your question, your Coley question. How do we implement a set for the manufacturer? Remember, it's still a char array, but it's a static one. This is the big difference between this and this. This is just a pointer. So you see, that's why we need to allocate it before we copy something into it. But this is static, which means it exists. You already have 50 characters. So here, set manufacturer. Okay, here I will receive const char asterisk new producer, say producer. Okay, now here if you try to, again, let's validate the new producer. So if new producer equals null pointer, and again, string length, let's check the name also of the producer. Let's implement the same rule of new producer is less than 3. Again, we throw an exception. So name is missing manufacturer, let's say, because it's related with the manufacturer. Manufacturer is missing or is too short. Okay, and else, let's write else. Okay, and else we do what? If you try to create a new array, fortunately, the compiler will stop you. If you try to say new char of string length of new producer +1, fortunately, the compiler will remind you that all the pointers for static arrays are constant and you can't change them. Why you can't change them? Because if you can change the address of a pointer which points to a static array, normally we will create a memory leak. So normally you should delete the previous array before creating a new one. Okay, this is the idea which we will implement it here. You see here we are creating the new array. Now, every time you define a static array, with a very high probability, those static arrays, if your objects are on that function stack, the static array will also be on that function stack. And remember that we can't ask for more space or delete space on a function stack. That's something which is pre-computed, and that's it. You use it or not. And the only place where you can actually create and delete space is in heap. So that's why they are forbidding us, they are stopping us to create by mistake memory leaks on a function stack, which we can't avoid by actually saying, if you want a static array, it doesn't matter if this is a static array for a char array or it could be for numbers, it doesn't matter. All static arrays behave in the same way. So if you want a static array, you can't lose that address. You can't change that pointer. And they did that by making the pointer constant. So that's why you see this, this value, which is the manufacturer pointer, must be a modifiable left value, which means it's not modifiable. And when a left value, which means the destination, okay, the value to the left of equals is the destination, is the variable which will change, okay? That's why it's called left value. And when it's saying must be modifiable, it means it's not modifiable, which means it's constant. So all pointers to static arrays are constant. So you can't do this even if you try, which is a good thing, because otherwise you will create memory leaks on stacks. Okay, so we can't do this. So you will say, so how do we continue? Remember, why do we do this here? Because here we want to make sure that we have space to copy the value that we receive. So for dynamic pointers, you need to do that because you want to be sure you have space. Now here, when you play with the static array, you are sure you have the space. By definition, you have 50 characters. So let's just copy it. So here I will say string copy underscore s. The destination is this manufacturer. The number of characters is string length new producer +1. And the value is new producer. Okay, so for static arrays, string copy s. For static arrays, you just go and copy the values, okay? You can't create space. So you can't create memory leaks. You may say this is an advantage. Yes, but we know that the limitations of static arrays are bigger and more numerous than for dynamic arrays. But yeah, you can't create memory leaks with static arrays. Okay, so this is the set manufacturer. Now, you see, we are using this 3. And the 3 is actually a magic number, not because this is the way they call hard-coded values in the source code. So this 3 is a magic number, but also 3 is a magic number because in many stories, 3 is a magic number. So 3 has this magic aura. And also in religion, 3 it's an important number. So, but nevertheless, every time you pass here and you hard code values, which you see we are using them to validate different stuff, those are called magic numbers. So what's the issue with them? The issue is that if someone will give us a name which is shorter than 3, we make the program crash. Let's suppose our colleagues know that. So here we will have a colleague which will ask these values from the user. And we will do that in the next minutes. And again, other colleagues will use this class for other stuff in order to build the online shop software. So they know that we have this limit here, 3. Now, what's the problem with magic numbers? Is that in 1 month from now, if you read this code again, maybe you will have hard times to remember what's this 3. Why do you check against 3? So that's an issue with them. The other issue is that if you want to change the limit, for example, if you want to lower the limit for names to be 2 or 10, you see what I did? I need to go through all my functions where I have this 3, but you may have other functions which are using the 3 value, but not for name. And you need to replace that 3. So it's not so simple as find and replace, because you may replace other 3 hard-coded values which have a different meaning for other functions. So this is another issue with magic numbers. And when you do this, when you update 3 to 2, or you go for 5, now your friends, your colleagues, which are validating the data here because they don't want to call you with a name shorter than 5 because they know the app will crash, they have no way to know that you updated this value from 3 to 5. So you see, you have a lot of issues with these magic numbers. So how can we avoid them? How can we write them more efficiently? By covering all these 3 cases, including helping our colleagues to know that, hey, our new limit for name is not 3 characters, it's 5, or it could be 2 again. Okay, how can we do this? And I showed you last week that in a class, we can define attributes which are a little bit special. Okay, they are not like name, manufacturer, price, sold items, and number of months. They are a little bit special because we define them static. So why we define them static? So let's suppose we want to define this limit here. So here I'll define a variable called min name length. Okay, and you see I initialize it with 2. Now we can define a get method for this one. So our colleagues now they can check what's our minimum length for our names. So instead of writing here 2, now I can write this variable. Okay, here and here. And we can do that also with the price, because later we will also implement a set for price. So let's define another one, min price. And let's say the minimum price is 1 RON. Okay, you can't add something with 0. So 1 should be minimum. Okay. So now we have 2 variables. So what's the issue with this approach? Now, you see, all these are called attributes, but some of them are more important than the others, or there is a logic difference between this set and this set. They are all attributes, which means a product now has 5 plus 2, 7 attributes. But you see, there is a difference between them. Now, these attributes, they have a value to a product because they store the name, the manufacturer, the price, and data related to the product. But these 2 attributes, they don't help a product. They are helping us to validate here the new name length or the new price. Okay, so what's the issue? The issue is that if I will draw an object right now, so if we will draw how a product looks like into memory, we know it's a box. Okay, this is encapsulation. And we know that here you have all the attributes of this box. So you have here the pointer name, you have the manufacturer, okay, which is the static array. Let's write here just to distinguish between them, it's 50. Okay, you have the price, you have another pointer, sold items, you have a number of months, and now you have also this min name and the min price. So what's the size of a product object? If we just add this, the size of all these values, we have here what? So we know that all our pointers in our examples, they have 4 bytes. We know that this is a static array of 50 characters, which means 50 bytes. We know the price is a float, so 4. We know this is another pointer, 4. It doesn't matter how many values you have here. There are in heap, but the pointer is here in the box. Okay, another integer 4 and another integer. And I think here I have a mistake. This is a float. Okay, because price is a float, so we can have a minimum value. But nevertheless, the size of a float is equal with the size of an integer. So again, 4. So what's the size of a product? Let's see, 54, 58, 62, 66 plus 8, 74, if I'm not mistaken. Okay, 74 bytes. But from all these 74 bytes, this 8 does not actually say something about the product. They are actually saying something about the minimum size of a name, but that's not the product job to know, okay, or the price. That's just for us, for the software. So you see, if you create 1 million products in your software, if you are like Amazon and you are selling, or I don't know, Alibaba, you are selling millions of products, you have these two attributes in all your products, because that's the definition of the object. So the object will have in its box all the attributes which are defined here. So you will have these attributes, but you will also have these attributes and all the attributes that you define here. So if you have 1 million products, 8 million bytes, because you have here 8 bytes multiplied by 1 million, 8 million bytes are actually used for almost nothing, because all these variables will have always the same value, 2 and 1. Now, another issue, what will happen if you want to update these two values? You need to go through your 1 million objects and say to them, hey, let's update the mean price and let's update the mean name. So you see another issue to solve. You'll have another problem. You need to update those values because you'll have objects with different values. So how can we avoid this? Now, I don't want to go back to magic numbers. Okay, I understood that they are bad, or they will create more issues in the future than actually helping us. So I don't want to go back to magic numbers to replace this with 2 or 3. So it's clear we need to define some variables. Now the question is where? If I define these variables here, we said we will never do that, and I will not. These are global variables. And another issue with global variables is that anyone can change them from anywhere. Again, we don't do that. So we are back to the class. So you see, sometimes you need to define some attributes which are related with the story, are related with what you want to do, are related with products, but we don't want to include those attributes in our objects box because it's just wasting time, and you need to manage those variables again, and at some point you will do mistakes. So in order to define some attributes in your class, because we can't define them globally, we don't want to define them globally, they have provided that this special class of attributes which are called static. Okay, so when you define a static attribute, you say, hey, these attributes are related not with the product object, are related with the story. So they are part of the story called product, okay, are part of my definition. But right now, these variables are stored only once, and this is very important. They are stored only once in memory. It doesn't matter where. So they are stored somewhere in memory here, mean length, and mean price. And they are not part anymore of each object box. So this will be a product. This will be another product. Now, what the products will have now? Only this. So all the attributes which are not static. So you have here this data here, which means 86 minus 8, 78 bytes. Okay, so 78 bytes. Okay, here 78 bytes. And all these 78 bytes are actually something, they have a meaning for a product, the name, the manufacturer, and so on. So these 8 bytes will exist only once in memory, and we can access them from our class. And that's why this is the way static attributes are managed. Okay, so statics are a little bit like globals. They're actually handled as global variables, but we don't care. They are not globals. We don't say that. Okay, but they are very close to global variables. Okay, but they are related also with the product class. Okay, so these static variables exist in all object-oriented languages, and let's see how you can use them, because there are many ways to use them. So we know now that instead of defining this as normal attributes, now we define them static. So now here I have this static and this static. And because static variables are a little bit special, okay, we just saw that, so they are not stored inside each object. The naming convention which is used to name them is using caps, and this is the way we will also name them. So mean, name, length. Okay, so we will define all our statics with caps, mean price. Because when we will see one, you will instantly know, hey, wait a minute, that's special. It could be a static, so you know it's a static. That's the naming convention. So let's use this mean name length here and here. Now, when you define a static variable in a class, the official way to actually use it is to also use the class name as a prefix, like we have used the standard namespace name. So the official way is here to actually write product. Okay. And when you do this, you see you have mean name length. But again, you can see you can use it without the class name specifier. I will always use this class name specifier because for me, it has many advantages. For example, if I see the class name specifier here, I know that this is a static variable from this particular class. You can have solutions with many classes, each having their own static attributes. So in this way, if you use all of those, at some point, you will not know from which class you are using that static. But if you are using the class name specifier here, you know for sure. And again, when I see this this syntax, when I see the name of the class with the 2 points, I will know for sure this is a static, because it could be also be a normal attribute and the developer has used caps. I don't know for which reason, but yeah, it could happen. So when I see this, I know for sure this is a static, because this is the way to call statics. But if you use them directly, it's okay, it's still working. But watch out if you have multiple classes, watch out which you refer or don't mess them up, okay? But from my perspective, you will always see me writing this. Okay, so this is one way to use static variables. We can use them to replace magic numbers in our source code by defining values like limits or important values for us. Generally, there are limits or things to validate against or something like this. Okay, now we have an issue, and this is specific to C++. Fortunately, in Java, C#, you don't have this issue. And now the issue is this error. So if I check the error list, it's saying, and we have two errors here. It's saying that a member with an in-class initializer must be constant. And this is strange, because if I remove the static, it's okay, because I just told you, hey, always initialize your defaults. So if I add the static, it's not okay. And yeah, this is C++. Sometimes the rules are not so, I don't know, logic. It depends on how the language evolves, because in the end, they are actually using global variables to store them, but it's transparent to us. So the issue with static variables in C++ is the syntax that you need to use in order to initialize them. And this is what I showed you last Tuesday. So in order to initialize a static variable, you can't do it here. In Java, C#, you can, and this is the logic and natural way, but not in C++. And this is the only way to do it. So you can't initialize them here, and you need to go here outside of your class. So you need to be out of that class, and you need to redefine them. And now the class name specifier is mandatory. So here, and this is another reason why I will always write this, because I will have only one rule: always write this. Okay, I don't need to worry when to write it or not to write it. So here you need to do this float and redefine it. Okay, why do you need to redefine it? Because if you don't redefine, if you don't use the class name specifier, this is actually a global variable. Okay, and you have no error. So that's why this is important. And here is mandatory. And this is called the class name specifier. Okay, because here you are actually telling to the compiler, hey, this is the static variable from product. Let's initialize it with 1. So here I will say int product, mean name length equals 2. Let's say 2 characters or 3, whatever, 3. Okay. So this is the only thing, let's say, strange about static variables in C++. You need to initialize them like this, and there is no other way. Okay, I can't do that differently. Okay, so with static variables used as storage for important values or at limits that we will use for validation, you see, I removed the magic numbers from here. And now any developer which is trying to use our product class in order to create a product and it's asking for a manufacturer or a name, now they have the possibility to actually check this because they will need to validate. So if I try to print this value, and remember, now they are private, but I can make them public. Okay, so now I can have them public. Okay, and you have now public mean name length, mean price. Now I can check, now being another developer. So now let's imagine we are another developer. So now we can actually check what's the minimum length that the product class requires for name. So minimum size, minimum length for the name is product mean name length. So if I hit build, rebuild, okay, and run this. Okay, and let me show you. You will see minimum length for name is 3. So you see right now, all our colleagues, all the other developers, now they can actually validate the values that they are going to pass to this function, set name, set manufacturer, before we throw an exception. So now they will be sure they will not get back an exception because they have the power to change, to validate. So this is one way to use the static variables. And I will show you till the end of today's seminar another way to use them. Okay, so let's finish the set methods. So here, let's go for set price. And after that, we take a short break. So void set price. And here I will have float new price. Okay, and again, I will validate. So if new price is less than product mean price, then I will throw an error. Throw exception price, wrong price. Okay, else this price equals new price. Okay, so right now we can validate also the price against the minimum price, which is a static variable. And at this point, you see statics are used just to replace those magic numbers in our source code. So if we want to change the minimum length, you don't need to go through functions and replace 3 by the new value. You just go here and say, hey, let's create another software in which the minimum length is 2. So right now, every time you use mean name length, name length, and also your colleagues' software is updated. Okay, so it has more advantages than using hard-coded values. Okay, so this is remember statics from last course. If you have any questions up to this point, if something is still not clear. So this is the way you initialize them, and this is one way to use them, but I will show you another way.
I actually have an error if I can show you.
Please.
Oh, one moment.
Okay, so we have seen one way to use the statics. Now let's finish the other set method. We still have a.
Oh, I'm sorry to interrupt, but yeah. I have. Oh, never mind. I just saw what the problem was.
Ah.
I didn't have the price defined anywhere, and I went where you defined it. And
and you had an error here.
yes, exactly. And I have another error on the static int min name length on the top of the screen where we
Here.
defined it earlier. Yes.
But you still have here equals 3.
Oh yes, I still had it.
Yeah.
Thank you very much. I'm sorry.
So yeah, we are not allowed in Java, C#, and all the other languages. You can do that because it's natural to initialize it there, but not in C++. So yeah, this is one of the many rules which are, let's say, strange. Okay, so yeah, you can't do it here.
Okay, thank you.
Okay, great. You see, sometimes just asking, it's helping you to focus. So that's why I always ask. Because sometimes just asking you can see the error on your own. Oh, okay, so let's finish the last set method for this field because we need it here to complete the constructors. So here let's write the set void set data, let's say, and here I will receive a const int. Let's just scroll a little bit up. Okay, so this is the previous data, and number of records. Okay, which is actually the number of months for us. So here again, avoid shallow copy. We need to do this. It's another dynamic array. So this sold items per month equals new int of number of records, which is the value that we received there. There is no string copy. There is only 4. So for int I starting at 0, I less the number of records, I plus plus. Now we say this sold items per month index I equals with previous data at index I. And don't forget to initialize your number of months equals number of records, because now we have a different number of values here in the sold items per month. Okay, and this will be the set for the other dynamic array. So right now we can initialize all our data. We have set methods. So this will be a good moment to actually finish the constructors, because you see, if you don't implement the set methods, everything you wrote here in set data, with everything you wrote here in set price, with everything you wrote here, and so on, you need to write here. So that constructor will have like 13 lines of code, because you need to do all this stuff that we did in each set method. You need to do it here if you don't have the set methods. And after that, you need to copy paste everything what's here, or you need to write it again. So that's why it's better to take each attribute one at a time. And remember, if you don't want to allow others to use the set methods, just make them private. So if I write here private, now the constructors are public, but the setters are private. So I'm the only one who can use them. Okay. So always you have the power to decide what's visible, what's accessible, and what is not. Okay. So because we have the set methods, now defining the constructors or any other function which will change either of those attributes, it's very easy. So now I just say this set name of name. Watch out for shadowing. Okay, remember I explained you what's that last Tuesday. So this set manufacturer, this set price of price, and this set data of previous data and the number of records. Okay, the values that we get there. So you see the constructor, it's much more cleaner. So we have name, manufacturer, price, and previous data. I think we covered everything. And again, the validation is done by set methods. So if someone is trying to call the constructor with a wrong name or a wrong price, the application still crashes. Okay, so they still have an error here because set will throw an exception and that exception will also interrupt the constructor and so on. Now, for the second constructor, in this case, we don't receive previous data. And here is like you create new products, okay? You have new products for which you don't have previous data. So in this way, for this objects, we initialize only the name, the manufacturer, and the price. Okay. So right now we have the constructor, we have the set methods, so we can actually test them. So let's build some products and let's remember what are memory leaks and why we need to clean up and how to do that to clean up memory leaks. So we will analyze the source and we will identify the places where memory leaks will be created, and we will avoid that. Okay. So let's test the class. Let's do a build rebuild before writing new code. Okay, so in my case, it's okay. I don't have any errors here. So let's create a product with previous data. For example, we have a laptop and I don't know, we have some previous data. Now we have it back in our offer. So let's name this previous data. It's an array, but we also have the values. So like 5, 23, 10, 7. And here I'll say number of months equals 4. So let's create the laptop. So product, laptop. And here the name will be, I don't know, X21 Gaming. Okay. The manufacturer will be, I don't know, Asus, whatever, it doesn't matter. The price will be 2,400. And we also have previous data. So previous data and number of months. Okay, so now we have this laptop. We can create another one. Let's test also the other constructor, smartphone. Okay, so let's say S2000. Okay, Samsung, the price 3,000. Okay, there is no previous data. So let's say this is a new model. Okay, and now we can create all this stuff. Now, I told you that these static variables, let's finish the discussion with these static variables, are also important for our colleagues, which are getting data from users. And they know that if they will pass here wrong data, the constructor will crash and implicitly the application will crash. So these static attributes will help others to also validate in order to avoid reaching the point where we throw the exception. So let's simulate this case. For example, one of our colleagues is managing the console interface of the app. And now he's trying to ask the, I don't know, the accountant or the operator to create new products from the console. So our colleague is designing the interface, let's say in this way. He will have a static array for name, okay, just to store the name, to get the name from the console. He will have a manufacturer, another static array for the manufacturer, and he will have another array for a variable for price. Okay, and now our colleague will say this: cout end line product price, and here we'll read the value into price. After that, he will say cout, give me the name of the product. Okay, scene name. And the last one will be the manufacturer. End line product manufacturer. Okay, and now you will have seen manufacturer. Okay, and after the user will insert all these values, our colleague will create a product. New product. And here it will pass these values: name, manufacturer, and price. Okay. We don't have get methods and we don't have time to write the print info. to actually check this, but I will show you. I will show you that it will work. So you can extend this example by adding the print info, and you can test this further. Okay, now what I want to show you is what will happen if the user will insert wrong values. Remember, we have some validation rules. For example, price should be at least 1, and the name and the manufacturer name should be at least 3 characters long. So if we run this build rebuild, okay, let me share the entire screen to show you the pop-up. So if I will run this now, debug start without debugging, okay, now this will happen. So product price, let's go for the use case when the values are correct. So let's say product price 100 RON, mouse, manufacturer, I don't know, IBM. You see, everything is okay. So the product is created, exit code 0. If we would have a function to print info, you will see the info of the product. Now let's run this again. And now the user, by mistake, will insert the wrong value. For example, let's say -23 by mistake. Name, mouse, product manufacturer, IBM. Enter. You see, this is happening. And the reason for this error is us, because in the end, this -23, this value from here, has been saved here in price. And after that, from price, it has been passed to the product constructor. And from that constructor, which is this one, reached set price. And in set price, we have this. If new price less than that, throw exception. I told you I will show you how to see these messages, but we need to wait to talk about try catch. Okay, so this pop-up is created by us and our colleagues know that. So I said to you that these static attributes now are useful also for others, because they can now validate the values that they might get from the users in order to avoid passing us here a wrong value, which will cause this application to crash. So this is one way to do it, but now they can, because they have those statics. So here I can keep the user in a loop. You can extend this example by doing a loop for each attribute. So here I'm just simplifying it. So if I get the wrong value for either of the price or name, then I will ask all the data again. Now you can do this much more better by actually focusing on each attribute at a time. So I can do this with a do while. So for example, I will have this variable, which I will use in order to know that the data is valid. So is valid, I presume the data will be valid. Okay, and now I will do a do while. So do, because I want to check this at the end. So do here. Okay, what's this? We need a while. I said it's a do while. So while this is not valid, not is valid. So is valid. So this goes like this. We think the data will be valid. We validate the data against these rules because now we have access also to them. And if one of the values is not valid, we make this false. So the user will be in this loop until it will give us good values. So after we get the price, let's check the price. If price less than product mean price, we will print a message to the user, wrong price, and we say this is not valid, equals false. Okay, we do the same with product name. So after it will get the name, we will say if string length of name less than product mean name length, then again we print a message, wrong name, and we say is valid, again is false, is valid equals false. Okay, you can do that with the manufacturer. I will stop here. Now, if that will happen, the user will be forced to input data again. Here we are missing a semicolon after this while. So the user will be blocked here until we get some valuable data. So let's run this and let's see if now this will crash. So build, rebuild. And if I will run this, debug start without debugging. Okay, let's see. Product price, let's try -23. Wrong price, product name, it doesn't matter right now. We are in that loop. Again, product price, you see it's not crashing. 23. Product name, let's say A. Wrong name, blah, blah, blah. Again, 23. Product name, mouse, manufacturer, IBM. And now, now we are stuck into this loop because here we need to make this valid again. Is valid, true. So every time you start the loop again, you are optimistic that maybe this is the last time. So you need to make this true again, because otherwise it will remain false. Okay. So in this way, we can validate. And this is another advantage of static variables. So you see, now our colleagues will also validate because we force them to validate. This is the power of throwing exceptions. You make your colleagues do this. So they will not call your methods with wrong data because they know it will crash. So they want to avoid those pop-ups. So they will also validate. And at the end of the day, everybody wins because you have a more reliable software with less bugs. Okay, so that's why we throw exceptions to force them to validate, because otherwise they will not validate. Everybody will say, yeah, I know, but they say we don't need. And that's why you get errors. Okay, so this was one way to use statics. Now, let's go back to memory leaks. Let me show you how easy it is to create memory leaks, especially when you have dynamic fields. So you see here, we have these laptops. We have this laptop, and now the laptop is pointing to this array in memory. So can we change this laptop name? Yes, because we have a public set method, set name. So I will say laptop set name, and here I will say, let's call this one X22 gaming. Okay, so I'm changing only the name, and initially it was X21. Maybe later I will change it again. Laptop set name to, let's say, X22, because I realizing that was also a mistake, gaming. So what's happening each time? Each time we have the set name. So if I draw the memory of our object, it will look like this. On the function stack here, you have the laptop box. So this is, sorry, I want the free line. So this is on the main stack. So this is the product, and the product will have its data. Okay, we just computed the size. Now here you have that attribute, which is called pointer to name, at name. And this is a pointer. And we know that the constructor will initialize this pointer with an array which is in heap. How do I know it's in heap? Because I see new. So this is heap. Okay, heap. So every time, or the first time we have called set name in the constructor, we got the name here. So this would be the first name we set for that laptop, X21, X21 gaming. Okay. And this is where we have created this laptop for the first time, like here. Okay. And this pointer, it's pointing there. It has this address. Now, what will happen when we call set name? Let's go to set name. So if I go up and check set name, because we don't want to create a shallow copy, we explained that last week. Now we do this. This name, so look at this instruction. This name equals new char or string length of new name. And now you get the new name, X22. What's the effect of this new line? You get a new array in heap. This is the effect of new, this new here. Okay. And after that, you copy there x22. So here now you have x22 gaming. So this pointer, this name now will take this address. So now the pointer points here. A pointer points to only one address. You can't have a pointer which points to many addresses. So you just lost this address. And because you just lost it, so you don't have this link anymore. What's happening with this in memory? And this is the memory leak. Okay, this is it, where you leave something in heap and you can't reach that back. So this is the memory leak. The next time we call set name on this laptop to call it x_22 gaming, we will create another new memory leak. So every time we will change the name of the laptop, you will create another memory leak. And this will go on until we eat up 2 gigabytes. I showed you last Tuesday. Okay, so how do we avoid memory leaks? When you know that you will get a new address for a pointer, and that space is in heap, and you know that you don't need that space anymore, and you don't have any way to reach it because the only pointer which was pointing here will lose that address, and that's the moment when you create the memory leak. That will be the moment to avoid it. So how do we avoid the memory leak? Here, before changing the address in that pointer, you delete that space because you don't need that anymore. If that's the case, sometimes you may need, but you need another pointer to save that address. But in this case, we don't. Avoid the memory leak. Okay, how do we do that? If this name different than null. Now, one of your colleagues asked me, hey, why do you check with null? Because we have seen that it's okay to actually call delete directly. That's true. So in the latest versions of C++ compilers, delete is actually checking for null. Now, when I was starting coding, that was not happening. And trying to delete a null pointer was instantly terminated with a runtime exception. So because that was true for many years, this is the way, again, based on my bad memories, I will always check it. Okay, but modern compilers, they will do the check here. Okay, so you can call directly delete. Okay, if you like to do that. Okay, so we avoid the memory leak here. And now you should ask yourself, do we have any other dynamic field in our class which will change or has a probability to change? Yes, we have. And that dynamic field which will change is set data. So again, here, avoid the memory leak. Okay, so if you have at least one dynamic field in your class, check the locations where you actually change that pointer address. Okay, avoid the memory leak. So again, if this sold items per month different than null, delete this sold items per month. Okay, so now the set methods are okay. Now they don't create memory leaks. So this is the correct version, let's say, of these set methods. We don't need to do this for set manufacturer. Why? Because that pointer is always pointing to the same address. You can't delete that one. So you can't change the address here, but also you can't call delete on this manufacturer. You get the compiler error. So static arrays cannot be deleted. Okay. Now, is there any reason to create memory leaks? Let's look at the whole program, not just the set methods. So here on the main function stack, we have 3 objects, one laptop, one smartphone, and one that the user will want to create. So these objects are on the main stack. So what will happen when the main stack finishes, which actually means what will happen when the program terminates? When that will happen, we know that the function stack is destroyed, which means our products will be destroyed. But how a product looks like, let's draw it again. Because we know that a product is like a box. So this is our box. This is the product box. But we know that here inside the box, we have 2 pointers at name and at sold items, which are actually pointing to values in heap, because the arrays are here in heap. Okay, so they are in heap. So what will happen when the object is destroyed? Normally, the box is destroyed. So we don't need to care about this because this space will be released. The issue is that everything that you create in heap, it's your responsibility to delete it. So no one will ever delete something from heap if it's not you, like the system. So again, here, all these values will remain in heap when the object is destroyed. So every time you create an object, if you have dynamic fields which are managing stuff in heap, when that object will be destroyed, you implicitly create memory leaks. Okay, so how can we avoid these memory leaks? How can we have control on this moment when the object is destroyed so we can actually clean up this space? So last Tuesday, we have seen at the course that we have control over that moment because the destructor exists. So the destructor is like the default constructor. You get it for free. The same with the destructor. You get it for free. And the destructor by default will delete the object box. Now, what we want to do is to teach the destructor to do more than that, to actually release the space and avoid the memory leaks. So we have seen last Tuesday that we can actually define the class destructor in order to make it also delete the space in heap. So the destructor of product, now you can have multiple constructors, but there is only one destructor. So for this one, that's very easy. So here I will say tilde or whatever the name of that symbol is, product. So you see, it looks like the default constructor, but this sign here makes the difference because otherwise it will be the default constructor. So this was the way to distinguish between them. So now you have the destructor, and now the destructor will delete the box. So we don't need to do anything there. Okay, even if you define the destructor still is able to delete the box of the object. But now here we will avoid the memory leak. So if this name different than null, again, here you can write directly delete. Okay, delete this name. But I will always write this. You can call directly delete. If this sold items per month, different than null pointer, delete this sold items per month. Okay, so now we are avoiding those memory leaks. Now you will say, yeah, but who is calling the destructor? The destructor is always called automatically when the object is destroyed. So you may say, so are these 3 products destroyed? Yes. Why? Because the main function stack will be terminated. And let me show you the proof. So if I will print here a message, cout end line, the product destructor, and you see I didn't change anything in main. So main is still the same program. If we run this program, the last 3 messages that you will see are this. So build, rebuild solution. And if we run this, debug start without debugging. Yeah, this is the 23 mouse IBM. Here they are, product destructor. So who called the destructor? The system when the function stack, the main function stack has been destroyed. So you see, every time you define an object on a function stack, then I hope you have seen that. Let me run it again. I don't know if you have seen the screen, or let me show you again. So 23 mouse IBM, whatever. Okay, here they are again, the product destructor. So Every time you define objects on a function stack like this, laptop, smartphone, or a new product, when that function goes away, those objects are destroyed. And now we are actually avoiding the memory leak. Now, how do you call the destructor? So don't try to call it with this. Because if you try to call it with this is like trying to destroy the object on the function stack. You can't. Remember, you can't destroy space or deallocate space on stack. You need to wait for the function to do that for itself. So you can't actually call the destructor, but you can create the context in which you can actually see or control the destructor. For example, we can't create or destroy space on stack, but we can do that as many times as we want in heap. So let's create an object in heap. And let's say pointer to product. So equals new product. And here I will say test product just for testing. Manufacturer test and price 1000. Okay. And now, because this is in heap, I can destroy it. So delete pointer to product. Remember, what you create with brackets is destroyed with brackets. So here I'm just creating only one product. I don't have brackets. So when I delete it, it's without brackets. Okay, this is the rule for delete. So if I place here a message, cout end line after deleting test product, you will see the destructor message before this. Okay, because here I'm forcing that object to be destroyed. The object is in heap. I can do that. So here the system will also call the product destructor for this product. So build, rebuild. So this is the closest thing you may reach to actually calling the destructor, for example. Okay, when we will create objects in heap, we can delete them at any moment. Okay, you see the product destructor after deleting test product. Okay, so here we are forcing this object to be destroyed. Okay, so when you have dynamic fields in your classes, implement the class destructor because it's your responsibility to clean up after those. And if you have set methods or any other methods which are changing those values and you know you are creating new space for them, avoid the memory leaks. Okay, so memory leaks are always related with heap. And if your class will have at least one dynamic field, you will have one reason for a possible memory leak. If you have many other dynamic fields like we have today, 2 of them, each of those could be a source for a memory leak. Okay, so this will be a simplified rule to avoid memory leaks. Yeah, I can move. This is the destructor. Okay, like I said, you can simplify it by just writing these 2 lines. So you can ignore the ifs, or you can skip the if, but you just need to delete them. Okay, so this is about memory leaks, okay, and how we avoid them. Now, in order to end the day and end the discussion about static variables, let's see another use case for a static variable. So let's suppose we want to know in this software how many luxury products we have. So what's a luxury product? Let's say it's a product which has a value with a price greater than a limit we set. So let's define another static here. Let's say luxury limit. Okay, and what we want to do is to initialize this luxury limit. Okay, so I have defined another static luxury limit. So right now I will go here and initialize it. So float product luxury limit, let's say, is 10,000. Okay, so all the products which will have a price bigger than 10,000 we will say, hey, that's a luxury product. So we want to count them. So I need a variable which will count how many products we have created in this software, which are considered to be luxury products. So I want to control that variable. So again, I need to define a variable somewhere which is related with the product story. So I think a static is, again, another way to go for that. Because if I define a normal attribute, all our products will know how many luxury products are. It's like you, all of you, knowing at each moment how many students are in the faculty. Do you know? I don't know, because there is a dynamic here. Some are enrolled, some are expelled, some are just quitting, and so on. So we don't know how students are right now. We can know at the end of the year, but right now the secretary knows, but it's not our job to know that. So you see, that's why, again, I don't define it as a normal attribute, and we don't have the luxury, let's say, to define it global. So let's define it here. Static int number of luxury products. So this variable will not be used to store a value against we validate other values like mean price or mean name length. No, it's a variable that we want to increment each time we have a new luxury product. So let's initialize it with 0, because initially when we create this software, we don't have any luxury products. So int product number of luxury products equals 0. Okay, so we have this luxury product. Now, when should we increment this? You may say after you create an object. So after we create an object here in main, we can actually check the price of laptop, and if it's above 10,000, we can increment it. Also for smartphone, or also for the new product here, which is created based on the user data. Now, if you do this here, this is not our playground. You see, this is our colleague playground. This is the interface. This is the main application. This is the console app. So this is actually requiring asking our friend, our colleague, hey, every time you create a product, check the price against this. And if it's a luxury product, please increment this. Now, what's the probability that your colleagues will forget? Because you'll have other colleagues working on other modules. So it will be quite difficult to convince them to actually do this for you. Because you see, you ask them to do something for us. So they will say, hey, it's not my job. I'll do it later. I have other issues. Okay, don't bother me with that. So let's do this in our own playground. Let's not ask others. So what's the perfect moment to actually increment this variable? So to control it and to know at any moment how many luxury products we have. So let's print the value here at the end of the program. Okay, so cout end line, the number of luxury products is, and let's print it, product number of luxury products. So if I will run this, you will see that there are 0. Okay, debug start without debugging. Okay, this is annoying. That's why I avoid reading data from the console. It's becoming annoying. After the first time you test it, it's just annoying. You see, the number of luxury products is 0. So let's see what will happen if we make this smartphone to be a luxury product. I don't know. It's a gold smartphone, whatever, 34,000, which is above. If you run this program again, you will still see 0, because here you need to ask your colleague to check that price. But we don't want to do that because our colleagues will not do that. They will forget. You see, the number of luxury products is 0. So how can we control this static from our own playground? Remember, they can't create products without going through the constructors. Who controls the constructors? We control the constructors. Here it is. This is our playground. So we know that if they want to build a product, they need to go through either of these functions. So we can check the price here and we can increment the number of luxury products. So here we can say if this price greater than product mean luxury limit, we do this product number of luxury products plus equals 1. And you see, right now we will increment our own variables. So at any moment we will know this. And I can copy this also here. So if I will run this now, build, rebuild, and run it, debug start without debugging, blah, blah. You see, the number of luxury products is 1. Now we have control. Now, we can be smarter than that. And this is again the power of functions. Always write functions and reuse them. Now, when a product will become a luxury product, when it's actually changing its price, what will happen if we lower the price of a product? We have less luxury products if the new price is less than the luxury limit. So instead of doing that here and here, we realize that actually the number of luxury products is determined by the price of the products, and the price of the product is controlled by this unique method. Everybody will call set price to set the price. This is the power again of set methods, for example. So instead of doing this here and here, we will actually do it in set, and I don't need to copy paste this again and again. So I will go into set price here, and here before changing the price, because the price can lower. Remember, you have initially a luxury product, you realize you can't sell it, and after that you, I don't know, reduce the price and it will not be a luxury product anymore, and maybe you sell it. So here we need to take that also into account. So here I will say this: if the price before change, if the price is less than product luxury limit and the new price is bigger than that, than luxury limit, it means now we have a new luxury limit, because you see, you change the price, we have a new luxury product plus equals 1. Now, if this is the opposite scenario, which means this was a luxury product, which means the price was above luxury limit, and the new price is less than that, it means you lower the price, then you just lost a luxury product. So in this way, you update the number of luxury products when you have new products above that price limit, and you decrease that when you decrease the price. Okay. And remember that at some point, objects are destroyed, which means if that object was a luxury product, you just lost 1. So where is the moment when objects are destroyed? In the destructor. So here I will say this: if the price of the object which is going to be destroyed is above product luxury limit, then this object will be destroyed. So I need to update my number of luxury products, minus equals 1. Okay. So in this way, every time you will create new objects, you change their prices, you destroy objects, you have full control over this variable, and you can instantly know without actually going again through the objects and ask them, hey, are you a luxury product or not? Now you know how many of those you have. Okay. And again, this is one way to use static variables. You can use them to monitor this kind of stuff. For example, if you build an application with students, you can define a static variable called number of students with scholarship. So you don't need to query the database again and again. Hey, how many students have a scholarship? Okay, because that could be difficult. You need to check all your objects. And now you can update that variable on your own. So these are the use cases for static variables. They can be used for validation limits. So in that way, we avoid magic numbers. which are numbers hard-coded in the source code, or you can use static variables to count, to monitor something, to process some data which is related not with the object itself, but with the story around that class. It's you may say it's a value that represents all the objects. Okay, so these are the two different use cases for static. So you can increment them, you can decrement them, or you can use them just to store some values in them. Okay, so that's for today. Okay, as I said